Have you ever stopped to wonder how the software in something like a fighter jet or a satellite actually gets tested? Well, today, we're pulling back the curtain on the exact document that ensures this critical tech works every single time. This is the blueprint for trust in military software.
I mean, really think about that for a second. We're not talking about a buggy app on your phone that you can just restart. We're talking about systems where failure just isn't an option. So what's the game plan when the stakes are that incredibly high?
Well, here's the answer. It all comes down to this: a formal, super rigorous, and incredibly detailed document called a Software Test Plan, or STP for short. And let me tell you, this is way more than a simple checklist. It's the entire strategy for proving a piece of software is ready for its mission.
So what is it that makes this document the ultimate blueprint for trust? Let's break down what a software test plan really is and why it's the bedrock for building software that simply cannot fail.
Okay, so at its core, the STP is a comprehensive guide. It lays out three absolutely critical things. First, the exact environment for the test. Second, the specific challenges the software is going to face. And third, a precise schedule for every single activity. Nothing, and I mean nothing, is left to chance.
All right, so how does this plan actually work in the real world? It all starts with building what I like to call the test arena. Before you can run a single test, you have to set the stage perfectly, and the STP is unbelievably detailed about what that stage needs to look like.
First up, you've got your software items. And think about it this way. It's not just about the code you're testing. You have to document the exact version of the operating system, the specific compiler you used to build it, and any special test software. Every single tool has to be identified and controlled, because you want to avoid any surprises. You know, a slightly different compiler version could introduce some subtle, catastrophic bug that only shows up at 30,000 feet.
Next is the hardware, and the level of precision here is just remarkable. The plan demands that every single piece of equipment, from the main computer down to the smallest peripheral, is identified by its name, model number, and version. No substitutions allowed, period. If a test fails, you have to know exactly which piece of hardware was in play. There's just zero room for any guesswork.
And you know, it's not just about the machines. The plan even specifies the people involved. It details how many people are on the test team, what their skill levels need to be, and the exact training they must have completed.
So why all this insane detail? It all comes down to one critical word: repeatability. By defining the environment so precisely, a test run in California will produce the exact same results as one run in Virginia. It's all about removing variables and creating a true scientific standard.
Okay, so with the arena built, it's time to design the challenges. This is where the plan gets into the nitty-gritty of exactly how the software is going to be pushed to its absolute limits.
Now, tests are done at a couple of different levels. First, you've got what's called the Computer Software Configuration Item, or CSCI level. Think of this as testing a single part of an engine in isolation. Then you've got the system level, which is like testing how the entire car performs when it's all put together. You have to prove that both the individual parts and the whole thing are flawless.
And every single test, it doesn't matter if it's big or small, has a detailed anatomy. You have to state its objective. What are we trying to prove here? You define its type. Is this a performance test? Or are we trying to see how it handles errors? You list the exact data that needs to be recorded. And, most importantly, you link it back to a specific requirement. Every test has to have a clear purpose.
And that brings us to a really critical part of the plan: accountability. I mean, with so many moving parts, so many tests, so many requirements, how do you manage all of that and prove that you've tested everything you were supposed to?
Well, it all starts with a master schedule. The plan lays out the entire sequence of events, from setting up the test environment to conducting all the tests, and then finally analyzing the results and approving the final report.
But look, that schedule doesn't really answer the bigger question, right? In a complex system, you could have thousands of individual requirements. How in the world do you guarantee that every single one has been verified and that nothing has slipped through the cracks?
The answer is a really powerful tool called the Requirements Traceability Matrix. What you're seeing here is a simple version. On one side, you've got every single requirement the software has to meet. And on the other, you have the unique idea of the specific test or tests that were designed to prove it. This creates a completely unbroken chain of evidence from the requirement all the way to the proof. It's the ultimate accountability check.
So after going through all these layers of detail, the environment, the tests, the schedules, these matrices. Let's circle back to the big question. Why does all of this meticulous, almost obsessive planning matter so much?
Well, the document itself gives us the perfect answer. Right in its purpose statement, it says, the plan allows the acquirer, that's the organization buying the software, to assess the adequacy of the planning. It's a tool for oversight, sure, but it's really a tool for building confidence.
So at the end of the day, this is not about bureaucracy or just following rules for the sake of it. This entire exhaustive process is about building justifiable trust. It's about creating a mountain of evidence to prove, without a shadow of a doubt, that the software is ready for its mission.
And that kind of leaves us with one last thought. This incredible level of rigor is the standard for military systems. But what about the software that runs our finances, our transportation, our power grids? What blueprint for trust governs the technology in your life?